Tonight, we talk about a mission that was never meant to last this long. In 1977, Voyager 1 and Voyager 2 lifted off from Earth on a bold journey to explore the outer planets. Their planned mission time? Just a few years. They were built to survive brief flybys of distant worlds, and then fall silent. But scientists added something extraordinary to both spacecraft. A golden disk known as the Voyager Golden Record, filled with sounds, music, greetings, and images from Earth. Not for us, but for any intelligent life that might one day find them drifting between the stars. What no one expected was that these probes would still be sending messages back to Earth nearly 50 years later. After launch, the Voyagers began a rare planetary alignment known as the Grand Tour. First came the giant Jupiter. Its massive gravity slingshot the probes forward and revealed volcanic activity on its moon Io, powerful storms, and a complex ring system. Then, the breathtaking rings of Saturn came into view. New moons were discovered, and the structure of the rings was seen in detail for the first time. But only Voyager 2 continued onward. It became the first and only spacecraft to visit Uranus and Neptune, uncovering tilted magnetic fields, extreme winds, and entirely new planetary mysteries. What began as a short mission had already rewritten our understanding of the outer solar system. After the planets, the Voyagers kept going, toward a place no spacecraft had ever reached. They were heading for the boundary of the Sun's influence, a vast bubble called the heliosphere. This bubble is formed by the solar wind streaming outward from the Sun, pushing against the material between the stars. Scientists expected a clear, sharp boundary where the Sun's reach would end and true interstellar space would begin. The question was simple: what happens at the edge of our solar system? In 2012, Voyager 1 did something no human object had ever done before. It crossed the heliopause, the boundary where the Sun's solar wind gives way to the interstellar medium. Instruments detected a sudden drop in solar particles, and a rise in particles coming from outside our solar system. Magnetic field readings shifted. Plasma density changed. Voyager had entered interstellar space. But what it measured there was not what scientists expected. Scientists expected interstellar space to be thinner, emptier, almost nothing at all. But the instruments on Voyager 1 told a different story. The plasma density outside the heliosphere was higher than many models predicted. Even more surprising, the magnetic field direction on both sides of the boundary was strangely aligned, as if the edge of the solar system was not a sharp wall, but a complex, blended region. The boundary between our star's influence and the galaxy beyond turned out to be far more complicated than anyone imagined. Even now, nearly 50 years after launch, faint signals from Voyager 1 and Voyager 2 still reach Earth. These whispers are captured by NASA's Deep Space Network, giant antennas listening across billions of kilometers. To survive this long, the probes have been placed into extreme power-saving modes. Instruments are shut down one by one to conserve energy from their aging nuclear batteries. Yet they continue to send back data from interstellar space, making them humanity's most distant, longest operating explorers. The data from the Voyagers forced scientists to redraw the map of our solar system's edge. The heliosphere is not a simple bubble with a clean boundary. It is a dynamic, shifting region shaped by the interaction between the solar wind from the Sun and the interstellar medium beyond. Measurements from Voyager 1 and Voyager 2 revealed unexpected plasma behavior, magnetic field continuity, and a far more complex boundary than models predicted. Even decades after launch, their discoveries are still shaping modern astrophysics. One day, the Voyagers will fall silent. But they will keep drifting among the stars for millions of years, carrying the Voyager Golden Record and the story of Earth farther than anything we have ever sent.